Imagine waking up one morning in 2030 and realizing that most of the internet no longer runs on a handful of centralized cloud providers. No single company controls the infrastructure. No silent gatekeepers decide which applications survive and which disappear. Instead, the digital world runs on open, tamper-resistant systems that operate at web speed, scale globally, and are governed by code rather than corporations. This content is for educational purposes only. It does not constitute financial advice or endorse any investment or cryptocurrency. Information is based on publicly available sources. Always do your own research before making any financial decisions. Now imagine discovering that this shift did not begin with a sudden breakthrough, but with a project that has already been building quietly for years. A network designed not just to host tokens or smart contracts, but to replace the very backbone of the internet itself. That project is the Internet Computer. Most conversations around ICP today are trapped in short-term thinking, daily price swings, fear, uncertainty, doubt, endless debates about charts and narratives that change every market cycle. But those discussions miss the real story entirely, because the real question is not where ICP trades this week or this year. The real question is where this technology fits in the global digital landscape by the end of the decade. This is not a video about speculation. This is not a price prediction. This is a long-term vision, a clear, structured look at where the Internet Computer could realistically stand by 2030, how it navigates regulation, how it integrates artificial intelligence, how it expands beyond crypto, and why it may emerge as one of the most important pieces of digital infrastructure in the world. Forget the noise. Forget the fear. This is about fundamentals, trajectory, and inevitability. Beyond the hype, ICP's foundational pillars for 2030. Guys, 99% of people watching don't subscribe to this channel, so please take a second to hit that subscribe. It really helps the channel grow. To understand where the Internet Computer can go by 2030, it is necessary to revisit why it exists in the first place. Not the headlines, not the narratives, the actual design principles that separate it from every other blockchain. At its core, ICP was built to solve a problem that most blockchains never attempted to address: how to run full-scale internet services directly on-chain. Not partial logic, not back-end fragments. Entire applications, data, logic, and user experiences, all hosted on a decentralized network that operates at web speed. This is made possible by three foundational pillars. The first is unbound scalability. Unlike traditional blockchains that slow down or fragment as usage increases, the Internet Computer is designed to scale horizontally. New subnets can be added without disrupting the network. Capacity grows with demand. This matters because by 2030, blockchains that cannot scale seamlessly will be irrelevant to real-world applications. The second pillar is true decentralization. ICP is not decentralized in name only. It does not rely on a small set of validators or centralized infrastructure providers. Governance is handled through the network nervous system, an on-chain DAO that controls upgrades, economics, and network parameters. This level of decentralization is not cosmetic. It is structural, and it directly impacts resilience, censorship resistance, and long-term trust. The third pillar is performance at web speed. Most blockchains force developers to compromise between decentralization and usability. ICP removes that trade-off. Applications can respond in milliseconds. Data can be served directly to users without relying on centralized cloud services. This is why ICP is often misunderstood. It is not competing with blockchains alone. It is competing with the modern cloud internet. Much of the fear surrounding ICP comes from ignoring these pillars. When viewed through a speculative lens, its design seems excessive. When viewed through a long-term infrastructure lens, it becomes obvious why this architecture matters. By 2030, networks that cannot deliver scalability, decentralization, and performance simultaneously will struggle to remain relevant. ICP was built with that future already in mind: the AI-native Web3 revolution, ICP's strategic pivot. One of the most underestimated aspects of the Internet Computer is its positioning for an AI-driven internet. As artificial intelligence becomes embedded into every digital service, the question is no longer whether AI and blockchain will converge, but how. Most AI systems today are centralized by necessity. They run on proprietary servers, controlled by a few corporations, trained on opaque datasets, and deployed behind closed APIs. This model is efficient, but it creates massive trust, security, and control issues. ICP introduces a radically different approach. Because the Internet Computer can host computation, storage, and logic directly on-chain, it becomes possible to deploy AI models in a fully decentralized environment. Not wrappers, not references, actual execution. This enables transparent AI, verifiable outputs, and autonomous systems that do not depend on centralized infrastructure. By 2030, this capability could define an entirely new class of applications. applications, autonomous AI agents that operate independently, decentralized data marketplaces where contributors are compensated transparently, AI-powered governance systems that evolve based on collective input rather than corporate policy. This is not theoretical. Technical foundation already exists. What changes over the next decade is scale, efficiency, and adoption. As AI regulation increases globally, centralized models will face growing scrutiny. Transparency will no longer be optional. Systems that can prove how decisions are made, how data is used, and who controls the logic will have a structural advantage. ICP's architecture aligns naturally with this future. It does not need to retrofit decentralization into AI. It starts there. By the end of the decade, the most trusted AI systems may not belong to corporations. They may live on networks that were designed for transparency from day one, navigating regulatory tides, proactive adaptation for dominance. No long-term vision is complete without addressing regulation. By 2030, the regulatory environment for digital assets will look very different from today. The era of uncertainty and reactionary enforcement is already giving way to structured frameworks across major jurisdictions. For many blockchain projects, regulation is an existential threat. For ICP, it is a filter. The Internet Computer's governance model inherently reduces several regulatory risks. There is no single controlling entity. Protocol upgrades are decided on-chain. Ownership is distributed. These characteristics align more closely with how regulators differentiate between decentralized infrastructure and centralized financial products. As DAOs gain legal recognition, networks with clear governance mechanisms will be favored. ICP's network nervous system is not an experiment. It is one of the most advanced on-chain governance systems in operation today. By 2030, proactive engagement with regulators will be essential. Not resistance, not avoidance. Collaboration. ICP's ecosystem is uniquely positioned to demonstrate how decentralized systems can coexist with regulatory frameworks without compromising core principles. Clear rules do not weaken strong networks. They expose weak ones. As speculative projects fade under regulatory pressure, infrastructure-level protocols with real utility will remain. Regulation will not slow adoption of decentralized internet services. It will accelerate the transition away from unaccountable systems. ICP does not need regulatory chaos to succeed. It benefits from clarity. Ecosystem expansion, beyond crypto, toward global adoption. The true measure of success by 2030 will not be token metrics. It will be usage. The Internet Computer is not limited to financial applications. Its capabilities extend into industries that have barely begun to explore decentralization. Enterprise IT is one of them. Organizations spend billions maintaining centralized servers, managing security risks, and dealing with infrastructure failures. A decentralized cloud that offers comparable performance with improved resilience is not a novelty. It is an upgrade. Social media is another. Platforms built on centralized control have repeatedly demonstrated the risks of censorship, data exploitation, and algorithmic manipulation. Decentralized social networks powered by ICP could offer ownership, transparency, and permanence without sacrificing user experience. Gaming infrastructure, digital identity, content distribution, and data hosting all represent areas where ICP's architecture offers tangible advantages. For developers, the opportunity is equally significant. Building on ICP removes the need for fragmented stacks. No separate hosting, no external databases, no centralized backends. This simplicity accelerates innovation and lowers barriers to entry. By 2030, the most successful decentralized applications may not advertise themselves as Web3 at all. They will simply work, seamlessly, invisibly. That is when adoption becomes inevitable. ICP 2030, the decentralized Internet's unstoppable trajectory. When viewed through a long-term lens, the trajectory of the Internet Computer becomes clearer. This is not a project chasing narratives. It is a system executing on a multi-decade vision. By 2030, the Internet will not be fully decentralized, but the foundations will be set. Infrastructure choices made today determine who controls digital life tomorrow. ICP is positioning itself not as an alternative blockchain, but as an alternative internet stack, one where applications are unstoppable. Governance is transparent, AI is accountable, and users are not products. Short-term price movements will come and go, market cycles will repeat, but infrastructure endures. The question is not whether the world needs decentralized internet services. The question is, which networks are capable of delivering them at scale? The Internet computer was built for that challenge. The decade ahead will not be defined by speculation. It will be defined by systems that work. And by 2030, the Internet computer may no longer be viewed as a crypto project at all, but as something far more important, the foundation of a new Internet. If you find this deep dive into the future of decentralized technology valuable, support this channel. Make sure to hit that like button, subscribe to the channel, and turn on the bell icon so you don't miss future updates. Thanks for watching, and I'll see you in the next one.